Hello students, this video is to talk about geometric quadratic word problems. In other words, a word problem that starts with a geometric basis with a rectangle or some other shape, and then when you attempt to solve it, you get into a quadratic equation that needs to be solved. In general, the 4 steps in solving a geometric quadratic word problem is to draw the diagram, choose a formula or equation that fits the situation, solve the equation, and then use that solution to answer the question. So if you solve the equation, you get a number. Step 4 says to answer the question. So you might say, oh, that number is 15 feet or something like that. So we're going to try to apply these 4 steps to the word problems that I gave out in class. This first one talks about a roller coaster ride. Greg is in a car at the top of a roller coaster ride, and of course, just like any problem, we're going to try to annotate it. The distance of the car from the ground as the car descends is determined by this equation. So we have an equation here that's given to us, and it says that t is the number of seconds it takes the car to travel down to each point on the ride. The first thing says graph the scenario, and we're going to figure out what the graph is using the calculator. So I'll take out my calculator here, and then I'll ask it to graph this equation. So I'll go into the y equals menu, and d, y, it's both the dependent variable, so it doesn't matter which variable we use, and then same thing with t and x. T and x are both the independent variable, they're interchangeable. So we're going to put in 144 minus 16, we're going to use x squared, and then when I try to look at the graph, I don't get much amusement from it. It's a very boring graph. But you can see that the graph that they give us is scaled differently. Whenever you're given a graph that's scaled in a certain way, use that graph. Never try to change those axes, because the reason that they gave you the axes like that on the Regents exam or on my exam or on anything is because those are the appropriate dimensions of the graph. So I'm going to go to my table, which I'll get to by pressing second graph, and all of these values can be graphed. So 0, 144, 1, 128, and so forth. So we'll plot some of these points. 0, 144, we know that this is 150 and looks like it's skipping by tens, so 144 would be just about here. So I'll put a little point there. We also know that 128 is going to be 128 up. It's about here. And then we have 2, 80, which is just about here at this point. And then 3, 0, as you can see it landed here. So now what we can do is connect these points into a smooth curve, or as best we can do. So you can see that it's not a straight line, this is not a linear function, this is a parabola, it's a quadratic function. And I did the best I can here. Alright, so we don't need the calculator anymore. The first question says, how many seconds will it take Greg to reach the ground? Well, from the picture, we can determine that it takes Greg just about 3 seconds to reach the ground. So we can say, how many seconds will it take Greg to reach the ground? 3 seconds. And one way that we can justify that is because it's asking about the ground. And we know that when we talk about the ground, in terms of a quadratic, we're talking about the roots. And there is a root at 3, 0, so 3 seconds. What is the highest point the roller coaster reaches? When you look at this quadratic, the highest point that it gives you is this point over here, which is 144 feet. Another way to think about that, it asks for the highest point, so that is talking about, in other words, the y-intercept. So the highest point the roller coaster reaches, we would say 144. And it's not just a number, we need to contextualize it, 144 feet. What is the average rate of change between 2 and 3 seconds? We remember, or you should remember, that rate of change talks about the slope. So between 2 and 3 seconds, we're going from this point, which is 2, 80, to this point, which is 3, 0. So we connect that point with a straight line. And now our job is to determine the average rate of change between those 2 seconds. And in other words, we're looking for the slope. In order to find the slope, one way to do it is to figure out rise over run. So our rise from this point to this point is going down 80, and our run is going to the right from 2 seconds to 3 seconds, which is 1. So our slope is negative 80, because I've gone down 80 from 80 to 0, divided by 1, because I've run from 2 seconds to 3 seconds. Negative 80 divided by 1 is equal to negative 80. That's the average rate of change. And we can refer to the rate of change as negative 80 feet, which is the distance measurement, per second. Which is the time measurement. Last but not least, explain the meaning of the 0 in the context of this problem. Well, we know at that 0 point, Greg is no longer at the top of a roller coaster ride, he's at the bottom. So the meaning of the 0 is Greg has reached the ground. Okay, we're going to try to do 2 more geometric quadratic word problems. Remember our steps: draw the diagram, choose a formula or equation, solve the equation, and then use the solution to answer the question. So a landscaper is creating a rectangular flower bed such that the width is half of the length. So we know it's rectangular, and we know that the width is half of the length. The area of the bed is 34 square feet, so that we're talking about the area there. And it asks us to write and solve an equation to determine the width of the flower bed. So that's the piece that we're looking for. That's what we're going to circle to the nearest tenth of a foot. So the first thing I'm going to do is I'm going to draw my diagram. It's a rectangular flower bed, and I know that the width is half the length. So the width, we could use W, we could use X, we could use whatever variable you want. The width is half of the length though. So whatever the width is, let's say it's X, the length is going to be twice as long because the width is half of the length. So this measurement is not just going to be X, it's going to be twice as big, 2X. There are other ways to write this. You could have written X for the length and X divided by 2, or 1/2 X here, but I prefer this because I prefer not to use a fraction. Now it tells us the area of the flower bed is 34 square feet. So remember our steps. We've drawn the diagram. Now we have to choose a formula or equation that fits the situation. In this case, it tells us area. It gives us length and width. So it seems to me that the formula that we should use is something that uses area, length, and width. And we have one of those. Area equals length times width. And in this case, we know the area is 34. That's equal to the length, which is 2x, times the width, which is x. We can simplify that to say 34 equals 2x squared. We'll put this squared marker in here. Now our next step should be to solve this equation. So notice that there's a coefficient next to the x squared. We're going to divide both sides by that coefficient. So we'll divide by 2 on both sides. Need that divided by symbol here. So we're dividing by 2 on this side. And we're also dividing by 2 on this side. So instead of 34 equals 2x squared, we'll get 17 equals x squared. The last step is to take the square root of 17, and you can see that that's not going to go on evenly because 17 is not a perfect square. It tells us to the nearest tenth of a foot. So we'll take out our calculator again, and we'll determine the square root of 17. Okay, we have our handy calculator here. So we need to take the square root of 17, so square root 17, and we get 4.123, etc., etc., and so forth. We're looking for the nearest tenth of a foot, so in our answer here, it's going to be 4.1. We round to the nearest tenth. The 2 doesn't mean we round up, so the value of x is going to be 4.1 is equal to x. And 4.1 isn't going to be sufficient for an answer. That's our numerical answer. But remember, we have to go back and say use the solution to answer the question. So our answer is going to be x is 4.1 feet. That is the width of the flower bed. So we can even say the width of the flower bed is 4.1 feet. Last but not least, we're going to go over a picture frame problem. It's the same as a walkway or a border problem. It says a rectangular picture measures 6 by 8. Simon wants to build a wooden frame for the picture so that the frame picture takes up a maximum area of 100 square inches on his wall. So we have a picture and we have a frame. The pieces of wood, the pieces of wood that he uses to build the frame all have the same width. So he has pieces of wood that are all some width that we don't know. So we need to underline same width because that's an important piece of information. First, we have to write an equation or inequality that can be used to determine the maximum width of the pieces of wood. However, our first step, as you remember, is to draw a diagram. So let's draw that diagram. In this case, we're going to draw a rectangle. That's a square. We need a rectangle for the picture. That's 6 by 8. And then we also need a frame around it. So when we label this diagram, we're going to need to include all the measurements that we know. This one's going to be 6 inches. This one over here, I suppose the 6 inches would be width, right? Smaller. So 6 inches there. We'll get the 8 inches here. And that's the measurement of just the picture. And we know that the frame has the same width all around, but we don't know what that width is. So from here to here, we can say that that width is a number that we don't know. And as you recall, the number we don't know, we use x for that. So that's the width of that frame. We also know that the width is not just from left to right, but is also from top to bottom. So that is another x. If I wanted to identify the total dimensions, the trick to it is knowing that this piece is 6 from top to bottom of the picture is 6. But this whole piece from here to here is 6, the piece in the middle, plus x for this part of the walkway, or border, or frame, and x for this part of the frame as well. So the total width is going to be 6 plus 2x. And similarly for the length, it's not just going to be 8, it's going to be 8 plus 2x. And it's those two x's again because we're combining the 8 and then this x, which is part of the frame, and then this x, which is also part of the frame. So we have our diagram. Now let's write the equation or inequality that can be used to determine the maximum width of the pieces of wood. In this case, we're going to look for a formula or equation that fits the situation. Well, the thing that fits the situation is they gave us area. If they give you area, we're going to use area equals length times width. Our area is 100 square inches. That's a maximum area, the area of everything. Picture, frame, everything. So we're using the larger areas. I'm sorry, the larger measurements. 8 plus 2x times 6 plus 2x. That's our equation. And we could use an inequality for this. Technically it says the maximum area of 100 square inches. So these values could be smaller. So we could use the greater than symbol. But for our purposes and for the purposes of the exam that you're going to be taking, you could use this to represent the possible dimensions of this frame. Then we have to solve the equation or inequality to determine the maximum width of the pieces of wood. That's just taking this and solving the equation. That's our third step. So we're up to step 3. So we need to take this and simplify it. So we've written the equation down here, and we'll use the double distributive property. That turns it into this step. We double distributed the 8 plus 2x times 6 plus 2x. In this step, we combine like terms. 16x plus 12x is 28x. In this next step, we subtracted 100 from both sides. We get negative 52 on this side. The reason we subtracted 100 is because all of our quadratic equations should say equals 0. Now that my quadratic is done, I choose to use the quadratic formula to solve this equation. And you can see my substitution step here. It looks like a lot going on here, but all we've done is substituted the a, b, and c values from the quadratic into our quadratic formula. Once you get this, you can put the whole kit and caboodle into the calculator and press enter. You'll get two answers. One is positive, one is negative. The positive answer is 1.524, etc. We're rounding that to 1.5 to the nearest tenth, and there's our answer. The maximum width of the pieces of wood is 1.5 inches